Okay, today we're going to be doing lessons 7 and 8 for chapter 7 together, or lessons 8 and 9. So lesson 8 is going to be comparing exponential expressions, and lesson 9 is going to be about geometric sequences. So when we are going to be comparing exponential expressions, we're going to be given two sets of options for our investments in our banks, and we're going to have to determine which one is a better deal. Now, the important thing to make sure is that you are given the same amount of time. So sometimes they might switch it up and give you months for one and years for the other. So we just have to make sure that they're both given and turned into years. So Jennifer is trying to determine between two checking account plans. Bank A offers a monthly compounded interest rate of 0.15, and Bank B offers a 1.5 interest compounded annually, which is a better plan. So Bank A is already telling us where monthly is 0.15, and Bank B gives us our yearly interest. So what we're going to do is we're going to turn Bank B into also monthly. So we're going to take 1.5 and divide it by 12, and that would give us a monthly interest rate of 0.125. So looking then at the monthly interest rates, Bank A is the better bank. Bradley is trying to decide between two savings account plans. A bank manager told Bradley that Plan A is a quarterly compounded interest rate of 0.35, and Plan B offers 2.5 interest annually. So what we're going to do is we're going to divide the first one by 4 to figure out how much it is monthly, which is 0.0875. And we're going to divide the second one by 12, which is 0.208. So Bank B would be the better interest. A television analyst is comparing the growth rates of two different television shows. The number of viewers of show A is growing by 3.5% per month. The number of viewers of show B is growing by 38% per year. So we're going to take the second one and divide it by 12. 38% over 12 months is 3.2%. And so show A is growing at a faster rate. Now moving on to lesson 9, which is geometric sequences. We did arithmetic sequences back in chapter 3, lesson 6. And when we did those, we were looking for a common difference between our numbers. So we were looking for a number added or subtracted to get from one term to the next. So for geometric sequence, we're looking for a common ratio, which is a number that is multiplied, either a whole number or a fraction, because we're not going to do division here. Instead of saying divide by 2, we're going to say times by half. So we're only going to do multiplication. And we're going to figure out what that common ratio is, and then we're going to write it in an equation. So this first part says determine if the function is arithmetic or geometric or neither. So we're going to check here how much is the change to go from 1 to -5, subtract 6. From -5 to -11, subtract 6. And from -11 to -17, subtract 6. So since we were doing subtraction, this one is arithmetic. On number 3, we can see they're going down by quite a difference. So we know this is not going to be arithmetic. We're going to try to see if this is geometric. So to go from 108 down to 36, I'm timesing by a third. So if I take 108 times 1/3, it would be 36. And 36 times 1/3 gives me 12, and 12 times 1/3 gives me 4. So this is geometric because I am multiplying to get from one to the other. On this one, I have 3 to 3 over 2. That would be a division of 2. We're not, however, doing divisions. We're doing multiplication. So dividing by 2 is the same as multiplying by a half. Now when I try to take 3/2 times 1/2, I do not get 1. I get 0.75. So this is neither. Number 4, it looks to me like it might be an arithmetic. So to go from -2 to 4, I'm going to add 6. But then if I add 6 again, that does not get me to -6. So let's try multiplying. To get from -2 to 4, I'm going to times by -2. But then when I take 4 times -2, that's not -6. So this is also neither. So once you've determined if it's a geometric sequence, we're going to continue to use the common ratio to figure out what the next 3 terms are. So to go from 64 to 16, or from 16 to 4, I'm multiplying by a fourth. So now I'm going to take 4 times a fourth, which is 1, 1 times a fourth, which is a fourth, and 1/4 times 1/4, which is 1/16. This one I'm multiplying by 4, or by 7 each time. And so I'm going to take 196 times 7, which is 1372, times that by 7, which is 9604, and times that by 7, which is 67228. Now for the sequence, we're going to use G of n equals. For the arithmetic ones, if you remember from chapter 3, we used A of n equals. So G of n equals A, which is our initial term, times R, which is our common ratio, and then we're going to do it to the n minus 1 power, and n is the term that they're asking for. So this says write an equation for the nth term, so they're not going to give us something to sub in for n for this one. For the sequence, 896 to -448 and -448 to 224. So I believe that's timesing by -half. Yes. So we're going to write G of n equals initial term, which is our 896, times our rate, which is -half, to the n minus 1 power. Now for part B, it says to use 8 as our nth power. So when I do that, I get -7. Find the 8th term of a geometric sequence for which the third term is 35 and the ratio is 7. So this one's a little bit harder because they give me the third term. They don't give me the first term. So what I'm going to do is use my division, work backwards, and figure out what the first term was. So my first term was 5/7. If I multiply that by 7, I'll get 5, and multiply that by 5, I'll get 35. So G of n equals 5/7 times my ratio of 7. This tells me find the 8th term, so I do it to the 8 minus 1 power. So 5, 8, 8, 24, 5. Thomas is saving pennies in a jar. The first day he saved 3 pennies, the second day 12, the third day 48, and so on. How many does Thomas save on the 8th day? So we're going to start with G of n equals 3. My rate is multiplying it by 4 each time, and to the n minus 1 power, and we're going to put 8 in for n. And it is 49,152 pennies.